Welcome back to the channel's rock crawling playlist. Today we will discuss why it is easy to break a CV axle while climbing a waterfall. Most people do not realize it, but climbing a waterfall requires the highest overall torque requirements for a vehicle. The torque on the climbing CV axle becomes quite large very quickly and then dissipates just as fast. Let's look at a video clip of a razor breaking an axle while climbing a waterfall.
Back up a little bit, hey Glenn! Whoa, you broke an axle!
We see where the driver front tire is completely off the ground going into the climb. That means all the weight of the front of the vehicle now must be supported by the passenger front tire. Coulomb's law states that the traction equals the weight placed on the tire times the coefficient of friction. As the weight shifts onto one tire, the weight of the opposite tire is decreasing in the same amount and at the same rate. The same applies for torque. This routinely happens on the trail. So what makes climbing a waterfall generate extremely higher torques? It's all about the traction vectors. Traction vectors are always parallel to the tire surface. What happens in the video clip is that the rear tire's traction vectors are parallel to the riverbed, and the traction vector of the climbing tire is both straight up and parallel to the riverbed. The front driver tire is in midair and produces no torque. Without going through all the calculations, here are the relative torques that are required. They assume one of the front tires is off the ground. Torque climbing factor at 42 degrees, 1.33. Torque factor at level ground, 1.8. Torque factor at climb at waterfall is 2.91. Yikes. The lesson is, if you're going to climb a waterfall, make sure the front tire loadings are near equal as possible when starting the climb. As soon as the tire starts climbing, the torque required drops off significantly. So let's look at that climb one more time.
Back up a little bit, hey Glenn! Whoa, you broke an axle!
Thanks for watching.